Hi, my name is Tamara Coleman, and in today's video we're going to be understanding the heart's electrical system and how its ECG works. Have you ever wondered how your heart keeps beating on its own? It's all due to the heart's conductive system. It generates and spreads electrical impulses. Today we'll talk about a little bit how sinoatrial nodes, also known as SA nodes, create action potential, how the heart conduction system works, and how this relates to the electrocardiogram, also known as ECG. We start out with the SA nodes, sinoatrial nodes, action potential, located in the right atrium near the superior vena cava. This is where the heartbeat starts, and it's often called the heart's natural pacemaker. This process is driven by a chemical change across the cell membrane. Action potential and SA nodes are created by chemical changes that involve the movement of chemicals such as sodium, potassium, and calcium. Specialized pacemaker cells undergo a process of depolarization. This happens due to slow influx of sodium through funny channels. As membrane potential reaches a threshold, calcium channels open, causing the depolarization. Then, potassium channels open to repolarize the cell. By doing this, it resets it for the next beat, and this rhythmic activity, it triggers a heartbeat. Next, we start going into the heart's conduction system. Once the SA nodes fire, the electrical impulses start spreading through the atria. This causes contractions. Here, it reaches the atrioventricular nodes where there's a slight delay which allows them to fill with blood. This impulse then travels down the bundle of His into the right bundle branch and the left bundle branch. Then into the Purkinje fibers, which rapidly distributes the signals, causing these ventricles to contract. So you might be asking yourself, how does this all link to the electrocardiogram? But before we get into that, let's understand what an ECG actually is. An ECG is a monitoring system that controls the heart's electrical activity through its cardiac cycle. It detects small electrical changes that are a consequence of the cardiac muscle depolarization followed by a repolarization. We read an EKG based on the waves that it provides. There's three main types. We have P wave, QRS wave, and T wave. But what does this all mean? Let's start off with P wave. P wave represents atrial depolarization. Atrial depolarization is the electrical activation of the heart's atria. It initiates the heart cycle, and it is represented by the P wave on the ECG. Atrial depolarization is the process where the SA node spreads an electrical signal that causes both the left and the right atrium to contract. P wave is the first positive deflection before the QRS complex, and it ensures coordinated atrial contraction. Next, we're going to explore the QRS complex. What does this mean? QRS complex is responsible for causing ventricle depolarization. It also causes blood to get pumped out into the body. In adults, the normal QRS duration should be between 80 to 120 milliseconds. And last but not least, let's explore the T wave. The T wave represents ventricle repolarization, preparing the heart for its next beat. This incredible electrical system keeps our heart beating in perfect rhythm. Without our sinoatrial node, SA node, working properly, our atrioventricular node could potentially take over, but this would make our heart beat much slower than what it's supposed to, approximately 40 to 60 beats per minute. Any disturbance in the electrical pathway of the heart could cause irregular heartbeats, which are commonly known as arrhythmias. In conclusion, the conductive system of our heart is such a crucial part of our cardiovascular system as well. Without it, we wouldn't be able to initiate or coordinate any electrical activity going through the heart, depleting us of being able to pump blood in and out of it.